Hello, my hosts, and welcome to a Haskell programming stream. Today, we are going to be removing a whole lot of the code as we try to migrate it over to our new Bezier curve system. So let's get on with that right now. Hi, Flamer Phoenix. Yes, you were the first here. So I'm going to use the error messages as debugging guides. I am going pretty well. All right, where are we? Not sure if you heard that. There's a bird outside being quite loud. 2, 3, 1. Strip you away and say undefined. Undefined. Hello, New Haven from Oklahoma. I thought New Haven was somewhere else. All right. There. All right. 227. We strip that away as well. Basically, the idea is we're going to remove all this code because we're going to be doing it in a different way. 182. All right. Undefined. Oh, no. 101. Oh. Union applied to 3 arguments. That's curious. Now I am so OP2 not meant to be applied to arguments. It's now I'm trying to work out what's going on here. Got to what is going on? So it's edge path path. All right, so let's have a look at render. What's this? Line 101. Yes. So render's taking in ST shapes and returning a shape. And we've got a shape here, which is spline. It's a boundary. So, yes. Render A, render B, just biome. That's going to have to... take arguments like that. So, I'm going to go data. Shape spline boundary and going to go or Boolean or set function OP to then shape. Where are we? 101. Shape. May be biome. Let's check if that parses. Monoscope biome. But we know that biomes exist. Boundary, path, boundary. Ah, that's BT node 4, maybe. How? Loop biome. STBG. ST closed. What type is the biome? BG will tell us, I hope. Oh, biome there, okay. Just adjust that. Well, that's not helpful, is it? Just trying to work this out. Might be ST biome, st.biome. Nope. BT biome. That's better. Biome tree. Biome tree. There we go. BT node 4. That's what we want. Where are we? I've lost track of where I am. BT node 4. let's load that up. And that's wrong. There. Okay, you are, what are you? Set function. Copy like that. Go to 102. I think if we go like that, that should eliminate that error. Yep. Okay, move back along here. Good. Wow. That got rid of all the errors. But of course, not having all the errors doesn't mean we actually got working code now. Just means we don't have any errors. Especially since a lot of this is plugged in with to-do messages and... Right. Now, let's go over st path. Okay, you turn a context into a point. Point is XY coordinates. And a boundary is that. We're going to change our boundary to be a... think a 3D spline. So change you to be boundary. So you are D3. This is a spline. And we just call it a spline. So 3D spline and a biome, which is basically our texture. And boundary. This data structure describe the outside degree of a shape and the texture that this shape has. All right. Now that we've changed all of that, things are going to break. Let's have a look. Yep. So our render closed path. So our first thing, 1, 3, 4. What are you doing? So you take in biome st thing and you return a shape. All right. Loop. Biome. Spline. spline. So let's have a look at our things here. Let's just move you down onto that lower one. So loop biome, spline, driving show, spline point. I'm going to use the root of the spline thing as well for reference. All right. Where is our spline? That's that one. So spline. So that's curve, A, spline thing. So this will be end. Driving show. Cool. Loop bind. Right, so this will be render on closed path. You are turning a shape. Oh, shape. Spline boundary. So, right, I've lost myself. Again, this is fairly typical for me. So, rather than saying loop, and right. Just that needs to be the same value as the starting point. Right. Render closed path needs another argument. So where does render closed path get called? I know what we do. We go render closed path. D3 dot point into path there. And I'm wondering if this should be a D2. Oh, my brain is getting overwhelmed a bit. Okay, let's just try and render a single frame. ST path. This is a path through space-time. Okay. All right, I think we actually just have to remove render closed path from the code base for the time being till we work out what to do with it correctly. So render closed path. And in fact, No, that's not what we want. How do we comment all of this out? Do not know. We can do it manually. All right. I'm just going to remove all of this code for the time being, because this all probably needs to be rewritten. Oh, don't want that. And open path. Just going to check in manual. Visual code. Video code. Comment. Multiple lines. How do we do that? Shift Alt A. Okay. Shift Alt. And path. Select all of that. They're all commented out. Oh, I did not know you could comment out that style. All right, let's load that up. Failed. In shape tree? All right. End. Okay, it's render path. Comment you out. All right. Oh, didn't I save it before I ran it? Let's go. 197. All right. It's the render point. We'll comment that out as well. And then we'll slowly bring things back as we work out how to use it properly. All right. Render open path 94. This is the whole render thing. All right, all of that works. It's just the render open path, so we can just undefine that. All done. Render closed path. Where do you go? 47. Undefined. All done. 41. Undefined. But this is basically me stripping out code to make it simpler so I can work out what to do and how to fix everything. Okay. Right. There. That's what. Excellent. Okay, let's write up what we're supposed to be doing. Okay, this is our ST biome, which is our background. Everything is inside the background. Okay. So this has to be treated differently to a boundary. I think actually we're going to do that as a separate thing. BG T dot node 4. So actually, thinking about it, we don't do that. Okay. So it should be a box from 0, 0 to 1, 1, representing a shape that fills the entire screen. Okay, that's for the background. Cut that off. What's that? So it will be a like that. So I'm going to say and do we have a quad structure? Oh my god. ST tree. Point path curve circle n-gon. Easy enough to write it as points in a path. Maybe how are we going to do this? It's a question I'm asking myself. Regular n-gon. So, this is a shape, so let's define that. Shape, and it's going to be a spline. Oh. So it's going to be shape. We've already started. It's going to be spline with a particular boundary. boundary, okay. We feed that into spline, okay. D3 spline, where it goes. We're going to find that. And right, you. Okay. Spline, so that boundary, sorry about this. So boundary takes, I'll go D3 dot curve. That should, yeah, it rebroadcasts spline and all those things. D3 curve. And you take D3 dot point. And it should actually be D2. Line D2, D2. That's better. D2 point 0, 0. Or 0. D2 point 0, 1. D2 dot point 0, 0. So basically we are drawing a Bezier curve. And then the subcurve of that will be D3 dot curve actually make it easier for us. Undefined. We'll start from that. Hold on. Let's bring you up to check if we are doing our code right. Okay. Yep. Sure, that's loading. Yep. Okay. The way we get around this part of the problem, where are we? I've lost myself again. Yep. Okay. Where? Upper right equals d2 dot point 0, 0, upper, actually up, that's upper left. Up. Then up right equals d2 dot point going x, y, so that's 1, 0. Up, down, left equals d2 dot point 0, 1, down, right equals d2 dot point 1, 1. So they're the 4 points on our screen. There we go. And we can like get those things to line up. Let's try that. And no errors. Then box equals D2 spline D2 spline. We don't say that. We say D2 curve from up left to up right. Ooh, ow. That was an unpleasant feeling. Up left. D2 dot curve. Up right. Down that should be down left and down right to be consistent. Down right. Up right. Open brackets. D2. So this is a Bezier curve. To make it straight, we are putting the handles on the opposite sides. So this is down, right, down, left, down, right, and D2 end. D2 curve, D2 dot curve down, right, down, left. This is down left, up left, down, left, to the end of D2, end, down, oh, sorry, up, left. Let's try that. Correct indentation or matched brackets. Is there an easier way to do this? Yes, there is. What did I do? That's not what I meant to do. The ends down. Left. Oh, that's the wrong word. Oh, so that should be up left. That's not what I want. I want to like that. Oh. Comment that out again. Save that. D2 end. Okay. Spline D2 does not export end. But it should re-export all the splined things. Type S. Huh? Switch to D2. Load up D2. Port qualified. Do I have to go D2 S dot end? That looks ridiculous. Okay. That's right. Spline D2 does not export end, but it should export all the modules from Spline. Yes. Do we need the import qualified? Okay. Oh, yeah, we do, because we do that. Once we go... All right, okay. Can I say D2 dot spline 19 D2 dot spline. Okay, cool. Not in scope. How do I say this module's version of spline? just remove that. And because it could either include... Okay, so I've got to say spline.d2.spline. Does that fix it? Thank you, Google Chrome, for telling me somebody made a comment on my comment. No module. Yeah. Okay. Go up to 10. Spline. Oh. Spline.d2 spline. All right. I want to export spline. Dot d2 dot spline. D2 end. Module spline. Then we re-export. Export dot go like that and go line dot spline. Think that will not in s dot spline. Splines d2 spline. Okay. And curve. Can I just go, actually, S go end and curve? No. It's in the... Oh, I know what we got to do. So we go... How do we... I don't think it's even a type. It's just a constructor. Curve equals s dot curve point type end equals s dot end point. Do you mean data kinds? A data constructor of... Did you mean data kinds? I might mean data kinds. What is a data kind? Data kinds. Data type promotion. Okay. Let's look up that says motivation. Rich type language, blah, blah, blah. Types. Back to that one. Data. To the kind level. Okay. Overview. Promotes that. Okay, type level literals. Promoted types. Type family type. Okay. Both the type and it's get promoted. That's not what we need to do. Not sure exactly what that means. I am going to have to do a bit more research. And we are coming up to the end of our streaming time. So I'm going to go back to my main room. Thank you for joining me as I worked on this project. Tomorrow we are going to be working on... Let's have a look. Well, actually, tomorrow we're not going to be working. We are going to be playing, and the game we will be playing will be... Where is that? Stellaris. So in our last Stellaris session, we started to integrate our next door neighbor, and this next stream will be continuing with the integration and expanding our empire. So I hope you'll be able to join me for that. Thank you very much. And if it's your first time watching, please consider subscribing. Thank you very much. See you later.